In section 9.2, we're going to be learning about arithmetic sequences. An arithmetic sequence is a sequence where the difference between consecutive terms is constant. The main thing that you want to take away from this is that an arithmetic sequence is where you're adding the same number every time, or subtracting, which would just be adding a negative number. We call that common difference D. And in a general, an arithmetic sequence would start with some value A. My next term would be A plus that common difference D, then adding that common difference D again, adding it again, and moving on from there. And in general, I can make a general recursive and explicit formula for an arithmetic sequence. A general recursive formula, remember, starts with your first term, which is A, and then my rule here would be I take my previous term and I add that common difference D every time. My explicit formula would look something like this. A sub n equals A plus n minus 1 times D. You'll probably use that one a lot more often. It's usually just easier to use in general. Definitely make sure you have all these formulas written down though, highlight them, just so that they're easy to refer back to. And before we get started with some examples working with these, let's just make sure that we can figure out if something is an arithmetic sequence or not. So in this first example, we're going from 3 to 6 to 9 to 12 and moving on from there. Remember, I'm checking to see if I'm adding the same number every time to get to the next one in the sequence. Looking at these numbers, it looks like I'm adding 3 every time. So my common difference is 3, and yes, this would be arithmetic. In the next example, I'm going from 1 to 4 to 9 to 16 to 25. So I might look at that and think, oh, cool, these are all perfect squares, that's the pattern. But remember, we're not just looking to see if there's a pattern. I'm looking to see, am I adding like a common difference or a common number every time? Going from 1 to 4, I add 3. From 4 to 9, I add 5. So I can stop there and realize there's not a common difference here. This would not be an example of an arithmetic sequence. So now let's work with some examples finding missing terms of arithmetic sequences, and that'll be it for today. In the second example, what is the 100th term of the arithmetic sequence that begins 6, then goes to 11, and then moves on from there? Even though I only have 2 numbers shown in the sequence, since I know it's arithmetic, I can already go up to my 100th term and find values from there. Since I'm going all the way up to the 100th term, it's going to be easier to work with the explicit formula here. Remember, the explicit formula for an arithmetic sequence is A sub n equals A plus n minus 1 times D. So let's plug in what we know here and then just plug it into our calculator. A is our first term, which we can see here is 6. I'm trying to find my 100th term. N represents what number term you're trying to find, so I'm going to plug in 100 for n. Only thing I have left to find is my common difference. Since this is arithmetic, I can look between any 2 numbers in that sequence. That's going to be the common difference for everything. So going from 6 to 11, I'm adding 5. This is arithmetic, so I know that my common difference for everything throughout here has to be 5. So from here, I let my calculator do the work. 6 plus 99 times 5 will give me 501. So that would be the 100th term of the following arithmetic sequence. And I'm done. In a different type of example, we want to find the second and third terms of the following sequence 100. Second term's missing, third term's missing. I see that the fourth term is 82. So the key to this is being able to find out what that common difference is. So I don't know what my common difference is, but I know that going from 100 to the second term, I have to add my common difference D. To go from the second to third term, I'd have to do that again. And to go from my third to my fourth term, I'd have to do it another time. So in other words, 100 plus 3 common differences would leave me with 82. So all I have to do here is solve for D or get that D by itself, and then I'd be able to find my second and third terms. So I'm going to subtract 100 from both sides, divide everything by 3, and now I'm left with D equals negative 6. So I know that that's my common difference. And that kind of makes sense here. So I'm adding negative 6 or subtracting 6 each time. I'm starting with 100, and I see that my fourth term is 82. So I'm getting smaller each time. So it would make sense that my common difference here is negative. So let's start to plug in our common difference, find our second and third terms, see that everything works out. 100 minus 6 will leave me with 94. That's my second term. Minus 6 again leaves me with 88. That's my third term. And just to check to see that it all works out, 88 minus 6 would in fact leave me with 82, which we knew all along was our fourth term. So we're good to go there. Last thing we're going to learn about is an arithmetic mean. This is just kind of a vocab word that you might see on like an ACT or SAT, so we'll just talk about it kind of once in this video, maybe talk about it a little bit more in class. The arithmetic mean, or average, of two numbers x and y is x plus y over 2. And how this relates in what we're talking about today, in an arithmetic sequence, the middle term of any three consecutive numbers is the arithmetic mean of the other two terms. So this might be easiest to see in an example. Here we have a similar type of problem as what we just did. What is the missing term of the arithmetic sequence 15 blank 59? Now we absolutely could use the same method of like figuring out our common difference and plugging in to find the missing term as we did in example number 2. But since we have three consecutive numbers, just another way that you could solve this is by finding the using the arithmetic mean to find that missing middle number. So since these are three consecutive numbers in an arithmetic sequence, what I could do here is do 15 plus 59 divided by 2, figure out that's 37. That would be my middle or missing term here.